Okay, hello everybody. So this is Standard 3 study guide. We'll just go through it. Hopefully it won't take too long. Okay, to start with the first problem, it's asking about the median, and then it kind of goes through some things. So is it the average of the highest and the lowest? That is not true. Um, this is a mistake that I see sometimes. Like if I have some kind of distribution, especially a skewed distribution, it does not fall midway. That is not what the median is. Um, the range of the middle 50%, this is referring to the IQR, so it is not that one. The average of the first and the third quartile, this is not true. This would assume that in a box plot, that the median has to be in the middle. The median can be pulled one way or another, depending if there's some skew or not. So it is not that one. Is it the middle 50th percent of the 50th percentile? And this is true. The 50th percentile means that, like here in the skewed data set, it means that like 50% of the data is here, 50, and then 50% of the data is here. So it's kind of like halfway in between. That is the true. And then the average of all the values, that would be the mean. So it is not the mean. For the second one, I have some summary data, and it's talking about alligators and complaints. So these are the complaints, and I have all the information, and then it tells me the z-score. So the z-score is the number of standard deviations away from the mean. It also has this formula. The formula and sort of the reasoning have the same math, just maybe not the same like what you're thinking in your head. So the z-score, it means the value minus the mean divided by the standard deviation gives me the z-score. The z-score, if I go 1.4 standard deviations above the mean, that gives me my answer. I rounded that, and this is 18. On to the second page, I have two distributions, raspberries and strawberries, and they have two different means and two different standard deviations. This first one here, this is strawberries because they told me um, they gave me a strawberry weight. They did not give me a raspberry weight. They said that's what I'm looking for. So they gave me a strawberry weight. So I found the z-score. And then they said they wanted a raspberry that had this same z-score. So I took this z-score and then used the raspberry mean and standard deviation. And I went from the raspberry mean of 4.5, I went up 1.497 standard deviations. Right, this is z, and this is my standard deviations above the mean. I got 5.25. Right, for number four, I've got, again, two distributions. I've got a calculator group and a non-calculator group. Something as you're looking forward for through. This is a mean and then standard deviation, and then I have another mean and standard deviation. And so I want to use those as I'm using, and then they said they wanted to know, they're asking about exactly 20 seconds for both of these. So I use them in both calculator group, non-calculator group. I get two z-scores, and they want faster. Faster means lower. So from the mean, I want the one that is farther away from the mean relative to the other one. So I look for this negative 1.44. That is farther from the mean. That's my calculator group. So my answer is A. Okay. For this one, I have babysitting, and they're logging hours and then $12 an hour. And so if I'm trying to compare the hours spent babysitting to the money, well, to calculate money, I would do hours, right? This is really hours times 12. That's going to be how much money she's making. This is my dollars. So if I know the mean hours, I would multiply by 12 to find the mean dollars. Standard deviation, multiply by 12. First quartile by 12, all of these by 12. The standardized z-score is the only one that does not get multiplied by 12 because this is measured in standard deviation. These two distributions will have those kind of same z-scores. Okay, on to number 6. This is one that you might not have been as familiar with, but I feel like I saw people making really good progress even though they weren't unsure, which was awesome. So it asked, I've got cumulative relative frequency, And cumulative relative frequency is actually is the same as percentile. So this is a percentile graph. And so if I look at the graph, even if you didn't know what that was, you still could find it because you go to 450 and you go up and you see that that's around 40%. So this is the 40th percentile, and this means that Miriam has the same or more followers than 40% of other students. And for the median is always at the 50th percentile. So I go to the 50th percentile and find that 600 followers. And then they wanted to know which had the most students. And that means like which one increased the most. So I see right here, this one increased the most. So I have between 800 and 1,000 followers because it had like that steepest incline. Okay, on to the next. So this one I have, this is movie theater tickets. And it's a little like that. It's a little like that multiple choice question actually, is that I'm taking these and they want to know from the tickets sold, each ticket costs $12 and they want to change the distribution. I have like all these summary statistics and I want to change them from tickets. These are all tickets and I'm changing them into dollars. So that means that really to find my dollars, it's number of tickets times 12. So for the mean, standard deviation, median, IQR, I just multiply them all by 12. And like here, my IQR, that I found that by subtracting Q3 minus Q1. And then I just took those, multiplied them all by 12. There's my answers. For the next one, I am taking the number, I really have like the number of tickets times 12 plus 500. And this is like my total. So the mean and median, they both are going to add 500. My standard deviation and IQR, the whole thing gets shifted up. So those stay the same. So they're just the same as the one right above. So I just copied those down and then I added 500 to those other two. So this last one is tricky, but this is something that's really important to remember. The Z curve, it is always the same. And it always has like zero, and zero is the mean and standard deviation of one. Okay, on to the next section, and this one is like some normal curves. So here I have this distribution. It's not perfectly normal, but it looks pretty darn normal. And then if I was to estimate 1, 2, 3 standard deviation has like pretty much everything. 1, 2, 3. And the like at 2, it's like pretty small areas. So I'm going to estimate that the standard deviation is 50. I think 75 is just a little too big. Like it's like it'd make that, yeah, a little like not enough. There should be a little bit left, like about 5% in my two tails, which looks about right to me. So here, when I look, these right over here, these lower numbers have really big, which means that like these would be like big peaks, and then it starts going over. So this is skewed to the right. Okay, in this one, I have 3 different values, A, B, and C, and they tell me what they are. So they tell me that um, so like A is the value of the third quartile, so Q3, and Q3 is at the 75th percentile. So I just wrote that down. And that's just by definition, right? They're quarters. This is 3 quarters, is 75%. Z score of 1 is 84th percentile. There are 2 ways to find this. Method number 1, I am going to look on my chart and I need to find one. This is the negative page. I go to the positive page and I look here and that is 84%. So a Z of 1 is the 84th percentile. And if I was going to do this on my calculator, I'm going to open up my phone calculator just because I feel like it's good for you all to see my phone calculator. If I go in here and I do second vars and I go to normal, it's like, oh, you know what? It's really not showing up on here. I don't know why. Let me see if that helps. That helps a little bit, but it's really not showing up. But anyways, if I go into my phone, maybe I'll try this calculator to see if you can see this better. I'm just going to use the regular calculator. Your phone will do it just fine as well. So if I hit second distribution and I hit normal CDF, the percentile, I want to have like a really small number. I'm going to put in a negative number because um, my mean is 0 and my standard deviation is 1. If you put in like -10, that's small enough, but I just put in -999. And when I hit paste, that also comes out 84. So in the calculator, it's good to remember that a Z, it has a mean of 0 and a standard deviation of 1. So you can use your calculator for Z scores as long as you know that. The last one, they give me a percentile at 70th. So if I'm going least to greatest, C is the smallest. So right away, I can see that the answer is E, but it should be C and then A and then B, and that's what it is. Okay. For number 4, I have a normal distribution. I have a normal distribution, um, and it has a standard deviation of 4.9. It does not tell me the mean, but it does tell me that the top 15%, so that's this piece up here, happens above 45 hours. So I have one value. So in order to find this, I am going to find a z-score, and I can either look at my table and look for an area of 0.85, which right here, I go to my table and I look for an area of 0.85, and I find that to be 1.04. Or I do inverse norm 0.85 and I use the z. So I use 0 and 1. If you're not sure what to use as mean and standard deviation, you can always, always, always use the z. You should leave it 0 and 1, and then you know that this is a z-score. So now I know that 45 is 1.036 standard deviations above the mean. So I could solve this, or I'm going to go backwards from 45. The mean is smaller than 45. I know that for sure. And you probably could have done that. If you didn't really know how to do this, you would know that like it has to be smaller than 45. So you could probably narrow it down to two choices, even without doing the math. You say, okay, top 15% is 45. That means that the mean has to be less than that because it's in the top 15%. So then when I solve this, I go 1.036 times 4.9, I get a 39.9. And this is it says it right there. It says that this is hours. Okay, so I'm finding I have, again, a normal distribution, mean of 58, standard deviation of 12.4, and I'm going in between 45 and 80. I can just do normal CDF, right? Second distribution, normal CDF. And again, if you're at home, I strongly recommend getting out your phone calculator. Oops, this should be 80. Mean is 58. Standard deviation is 12.4. And then you just type it in there, and then there's the answer. You're doing it on the Z table, you calculate two Z scores, and then you look up two areas on the table and subtract and get the exact same answer. Okay. Number 6 is really just asking about mean and median. The median, I put it about there because to me, if I shaded this, that looks like about half the area. This is about just visualization, so you don't have to be precise. One thing that if I was grading this, one thing that I would have marked wrong is that if somebody went like this, that is incorrect. And the reason this is incorrect is because this is definitely not half the area, not half of area. And what I can see that somebody did is somebody basically went like the min and the max and went exactly halfway between. And so this would be incorrect. I would be grading the following two things. As long as somebody told me that they were looking like about half of the area, and that's important, or 50% of the distribution, something would have had to been said about 50%, and that the median has to be smaller than the mean, and it shouldn't be directly in the middle. It's going to be a little towards like the peak. Not exactly at the peak, but but like towards it. So the mean is then a little higher as it is not resistant to the skew and would be pulled just a little higher. And something that I maybe should add in my answer is that the median is resistant to skew. This happened on the last test, and like I only took off like a half a point for this because people would say, "Oh, the mean is pulled by the outliers," which is true, and you should say the median is not to skew and outliers. Okay, almost done. Last problem, I've got the graduate record exam, GRE, and they have three sections, a quantitative reasoning, it's normal, mean of 150, standard deviation of 9. So I labeled this, I labeled 150, and then I labeled the standard deviations just like they ask for A, that's for A. So I feel like everybody should be able to do that. Here I wanted 141 and 168. These happen at precise. This is -1 z-score and this is 2. So if you know the empirical rule, you could use the empirical rule. For me, I don't remember, I don't always like, some of you are better actually at remembering what each little section is. For me, I know that the little tails are 5%, so that one tail is 2.5%. And then I know that I have like 32% and half of that is 16. Um, and then, so then I take 100 and I subtracted those. And this is my using the empirical rule. If you don't know the empirical rule, no problem. Just use normal CDF between those two numbers, look it up, or sorry, hit it in the calculator. And so I'll show it one more time just because if you're want to make sure everyone is able to do this skill. My mean is 150, my standard deviation is 9, and there I have 0.8185 or 86, and there's that one. For the next one, it wanted greater than 135, and 135 for this one, I did just, oh, here, I showed the work down here. So if you're using a z-score, 135, I subtracted, I got a z-score of 1.67. When I looked it up on the table, down here was 0.0475, so up above is 0.9525. And if I do normal CDF, I want greater than 135. I would put in 135 and a big number, mean, and then standard deviation. And I get that 0.9522. Okay, to get this last one, I just use inverse norm, and I got a score of 162 to be in the top 9%. It's important to know that like the top 9% matches the 91st percentile, so I put in 0.91. If you were using the z-score, you would go look up that z-score. And one trick to do is that if I went to the z-score and I was looking up 0.09, so I was looking for 0.09 and I go over here, 0.09, and I start getting close right here, 0.091, and I get -1.34. It's the same if I go to positive 1.34. Since I have a symmetric curve, it's like, sorry, I went to the wrong spot, like 1.34. Sorry, 1.34. If I was to find 90 per that 0.91, there it is right there. And so like 1.34 and -1.34, they are kind of like opposites. So like on the curve, if I have -1.34 or positive 1.34, like that's down, these tails have the same area. So here's 9% below, here's 9% above. So if you looked up, and you can see actually where I did that, I had looked up 0.09 and then I'm like, oh, that's not negative. And I just took away the negative and I could still solve for that. So just so you know. All right, everybody, hope this helped. Good luck on your studying. Please email with questions and I will see you all next week.